Leetcode problem 1887, reduction operations to make the array elements equal. Yeah. So for this problem, we are given a nums array, and our goal is to make all elements in nums equal. Yeah. But we want to make the smallest make all elements equal to the smallest element. Yeah. To complete one operation, so we're gonna do the follow those steps. So the first step is that we're gonna find the largest value in nums. So for this example, we're gonna find the largest value, which is gonna be 5, and let its index I and its value be largest. So this 5 is gonna be the largest. If there are multiple elements with the largest value, we're gonna pick the smallest index I. Yeah. So there's gonna be a lot of descriptions, which makes the problem really difficult to understand. Yeah, but if we check the example, it's going to be really easy to understand, right? So we're going to find the next largest value in nums strictly smaller than largest. Yeah, so let me just use an example. So, for example, we have some value like 135. First of all, we're going to find the largest element, which is this 5. And then we're going to reduce this 5 to the second largest element, which is going to be 3. So this is one operation. And next, we're going to find the largest element. Yeah, but if there are many elements, we're going to find the smallest index, which is going to be this one. Yeah. So what are we going to do? We're going to reduce this one to the smallest, which is going to be 1. Yeah. And the next, we're going to find the largest element, which is going to be this 3. And this is going to be the smallest element, and we're going to reduce it to 1. And how many operations? So in total, there are going to be 3 operations. So this is just the meaning of the problem. Yeah, I told you largest, next largest, you don't understand. Yeah, basically this is the meaning. So the idea is that we need to count how many steps, the total number of steps we need to make all the elements. Yeah, we're gonna reduce all the elements to the smallest number. Yeah, how can we solve this problem easily? So the basic idea is that we're going to find the largest element first, and then we're going to find the second largest element, and then we're going to find the smallest element. Yeah, so this is the idea, but there are going to be duplicate operations. So for example, we have 135, and for this 5, definitely there are going to be duplicate operations. First, because 5 is going to reduce to 3, and then 3 is going to reduce to 1. So this means for this 5, definitely there are going to be the duplicate operations. But how can we make use of the duplicate operations? Yeah, because let's just check what is the length of the nums. It is 5 times 10 to the power 4. Definitely we need to use O(n) time or n log n time to solve the problem. Yeah, because definitely n squared is not possible. Yeah, so what if we just sort the array first? What's gonna happen? So if we have a lot of 1s, so for example we have several 1s, and we have a lot of 3s, so those are 3s, and then we have a lot of 5s, so what's gonna happen? So currently we're gonna check it from the smallest to the largest. So this is 1, all those are 1. It doesn't matter because it is already the smallest numbers, it is 1. But what happens if this is 3 and this is 3, all those numbers are 3, so all those numbers are gonna be reduced to 1. So we can use the list group algorithm to solve the problem. Yeah, we just need to list all those 3s gonna be a group. So this is gonna be our first group. Yeah. And now we're gonna check the 5. So how many 5? Yeah, there are gonna be a lot of 5s, we just mentioned. So for all those 5s, how many operations should all those 5 should do the operation? It's gonna be 2 operations. First of all those 5 will be reduced to 3. And all those 3 are going to be reduced to 1. So this means there are going to be 2 operations, definitely. So we're going to check the length of the 5, how many 5s, and times 2. And here, the length of the 3 is going to times 1, because there's only 3 reduced to 1. But for 5, it's going to be reduced to 3 and 1. We just need to count how many groups for the steps. So the steps 3, step to 5. So there are going to be 2 steps. So in this way, definitely we're going to list the group 1, 1, 1, 3, 3, 3, and 5, 5, 5. So currently we're going to set a group equal to k equal to 0. So it means from here it's going to be 0. So how many 1s times 0? Definitely it's going to be 0. And here how many 3s times k going to be updated to 1? It's going to be times 1 going to be the result, and then we're going to plus how many 5s times 2, yeah, and then we just calculated the final result. So it is just the list group operation, and for this group, for the 5, definitely there are going to be 2 operations, because 5 need to reduce to 3 and reduce to 1. And definitely while we sort the nums array and we go through from the smallest number to the largest number, we can count how many groups. For here, this is the group 3, and how many operations? Only 1. But for this 5, because we've already counted this 3, it means there's going to be a group. So we're going to just update the k from 0 to 1, and from 1 to 2, while it goes to 5. Yeah. Now let's just use this kind of algorithm to solve the problem. Yeah. We're going to prepare I. It's going to be the index for the template, and yeah, I want to prepare n going to be length of the nums, and I want to prepare a result, and let me do like this: result I and n. So the result going to be my final result, and I going to be the index 0, and n going to be length of the nums. Yeah. After that, I'm gonna sort the nums, and I'm gonna prepare a k. So this k just means how many groups of 5 or how many groups of 3. Yeah. Now we just try to use the template, right? And here I'm gonna set j to I plus 1. So this is to list the group. Yeah. So while j less than n and nums j equal to nums j minus 1. So j gonna plus equal to 1, and what gonna be the result? Gonna plus equal to j minus I times the value k. So k from the beginning equal to 0, because it is for 1, it is 0 definitely. And after the calculation, k gonna plus equal to 1, and I'm gonna update the index I, which gonna be equal to j. Yeah. Finally, I'm gonna return the result. So everything from here, it is about the list group template. Yeah, so definitely I would like to use this kind of template, because this is just easy to do, and it is just O(n) times complexity. And after doing that, I'm gonna update the value of k. It means how many groups for this group of 3, or how many groups for this 5. Definitely for 5 it's gonna be 2. For 1 it is 0, and then for 3 we find another group, we're going to plus equal to 1. And then for 5, we find another group, so k going to update it to, update it to 2. Because here, from the here, k equal to 0, but after that, k going to be equal to 1. While we are checking this 3, k going to equal to 2. While we are checking this 5, k already be 2. After that, k going to become 3, but it doesn't matter because we have go out of the while loop. Yeah. Now let me just run it. As you can see, it works. Now let me just submit it to check if it can pass. As you can see, it's pretty fast and pass for all testing cases, and this is the best algorithm for this problem. Thanks for